Welcome back to this very spooky edition of the Software Circus. We have a speaker up next who's very important to the history of the Software Circus. But before I get into revealing their identity, a few shout outs. First of all, to our sponsors, Equinix Metal, Cycloid, Giant Swarm, Instana, and I believe Kinfolk came through at the last moment, but it's not on my list here. So I'm going to double check that one later. Obviously, Kinfolk, old allies of ours, along with many of the others. Go over to Brella and check out the virtual booths where you can meet people from all the sponsors and potentially get gifts. The other thing to point out is that after this talk, we're going back into another breakout fun, like track 3 session, which is pumpkin carving. I believe that's going to be a workshop style thing. And later there's going to be a competition judged by people from Equinix Metal. I believe it's my colleague Tom Crow, but I might be wrong. All right, that's enough for the shout outs for now. I have the great pleasure of introducing a speaker today who's spoken at many Software Circus events, but actually spoke at the very first Software Circus Festival in 2015 in Amsterdam. Now, I can't see the chat right now, otherwise I'd make you guess who he was, but maybe you could just reveal yourself. Or not. Okay, fine. Then we're just going to keep going with this. I'll do the reveal for you. I'm very pleased to have Michael Hausenblas from AWS with us today. Michael's talk is called Edward ServiceMeshHands. Michael, do you want to take it away?
I really practiced that a lot. I hope that went over smooth. So thanks a lot for having me. I'm really super excited being back in the Software Service Circus tent. And a big kudos, big shout out to our 2 girls, Rania and Safira, who did the makeup. Awesome. Rania is not only great at Python and Node.js, but also doing my makeup, so kudos to that. My name is Michael, and I'm an open source product developer advocate in AWS Service Team. And today, I'm gonna show you how Edward Scissorhand is something like ServiceMeshHands. And that is, they're both, can be powerful, can be very useful, but, you could also end up having some scars like myself here. So in the service team, in the AWS service team, I'm looking after OSS, open source observability, service meshes, GitOps. For that, I was at Red Hat, worked on OpenShift and Kubernetes upstream, Mesosphere, now D2IQ, that was Mesos. And before that at MapR as a data engineer, and I invested at some 10 years in applied research. If you want to follow up, if you want to have a chat, let's connect. You don't have to follow me on Twitter, although if you do, that's fine. The DMs are open, so it just can call me anytime, or good old mail works as well. So why are we doing that? Why should we be looking at service meshes? Let's step back a little bit and have a look at the good old monolith. I'm gonna reveal the monolith. And as you might guess from looking at that, this is some kind of e-commerce shopping solution, whatever. Details don't really matter. What matters are 2 things. And the one is that there are parts of that monolith, modules, whatever you're gonna call them. And there are connections to the outside world. So even if you do have a monolith, you do have egress, ingress, you have communication with all kinds of things. Think of fraud detection, you might get some, risk profiles from somewhere. Think of user management, you might have some sign up, single sign on solutions, LinkedIn, Google, GitHub, whatever. Think of payment options, you might be able to, pay with Visa, Stripe, whatever. So you do have all these ingress and egress points anyways. Now, if we move on to, slashing that monolith into many, many small microservices, then you get a lot of things that speak for it, right? You have increased development velocity, which means that potentially different teams may release different versions of the different previously modules in the monolith at different times. There might be, the teams working on user management, access control, might have a different cadence shipping their microservices than the render. And you can also have different program languages. You might prefer to write a renderer that delivers some HTML or some native apps in Node.js, whereas fraud detection is written in good old Java, whatever. And you get to use different data stores. You don't have to have one relation database that has all the data in there. And also what I call partial high availability, meaning that if, for example, fraud detection, you have memory blowing up there, not the entire app goes down, but only that part, you might be able to still, allow people to put stuff in their shopping basket, but maybe not to check out. So that's great. Awesome. We should all do microservices, or should we? Well, first off, you end up with a distributed system. It's scary already? Not scary enough. Now, because you have a distributed system and all these different services potentially end up on different nodes, on different VMs or different containers, you do have east-west traffic. So not only outside to the outside world, to third-party payment API or SSO or whatever, but also within the application, the different services, different microservices have to communicate. And now you also have an observability issue, because with a monolith, it's pretty easy. It's pretty straightforward. If I ask you, where's the problem? You can point at it and say, here in this jar file, in this binary, whatever it is. With a microservices setup, potentially hundreds of microservices, you do not know in the first case. It could be anywhere. It could be everywhere. So service meshes to the rescue, or not. Let's see. Before we get into what is a service mesh, maybe quickly review some use cases. You could, for example, and I really strongly encourage you, so that you don't end up like myself with cars, to look at something that gives you some immediate value, some return of investment, a clear return of investment. For example, you want to strengthen your security posture using TLS, MTLS between different services. You might want to do automated service discovery across compute. For example, you might have something, part of your application running as a monolith in on premises. You might have others as containers or a Lambda in the cloud. If you're already into GitOps, you might want to go a step further and do progressive delivery and deployment based on service meshes or enabled through service meshes. You remember early on, one of the challenges we've sought with service meshes is indeed observability. So all these things, the questions around monitoring, incident management, troubleshooting, committing to, and then being able to measure SLA, SLO, SLI, all of that is made possible through service meshes. You also want to ask yourself, where are you in your journey? For example, if your CTO, your CIO says, go do the cloud native transformation, do the digital transformation thing, very often you start off with the basics. You have your CI pipeline that is able to generate these artifacts, container images, Helm charts, etc. You might put them into something like ECR. You also pick some kind of orchestrator, very often these days, Kubernetes-based, some kind of compute, Fargate, for example, so serverless. And then, given that you might end up with a containerized microservices architecture, you very likely also want to have a look at a service mesh. So, before we go any further, I postponed that long enough. What actually is a service mesh? Two parts. You got a control plane, you got a data plane. That's pretty much everywhere the case, right? So what is actually in there? In the control plane, that's where you have the API. On the one hand, infrastructure ops folks would have a way to configure it, to set certain policies, etc., get metrics out there for the whole thing. On the other hand, developers would have application level configuration there. Say, hey, I want to have MTLS in this setup, for example, or this traffic shaping or whatever. And then you have the data plane, where you have next to your services that implement the respective part of the business logic, you have a sidecar, a proxy that intercepts usually a lot, if not all, of the communication. So if we look at the concrete path, at the concrete request path coming in there, end user talking to the front end service branching out. The logical view would be on the right hand side. The physical view is on the left hand side in the data plane. Everything here goes through the proxy. And with that, you have essentially a place where you can change things, where you can grab metrics, etc. And all the control plane really does, it configures these proxies, and that in a wide range of things. It could be in terms of metrics. It could be in terms of what kind of traffic to intercept or to allow, etc., etc. So in a nutshell, that is what a service mesh really does. Control plane configures proxies that intercept the services that actually implement the business logic. If you wonder how you should go about selecting a specific service mesh, I have 3 tips for you. And those fall into roughly these 3 categories. On the one hand, you want to be very clear about your runtime environment. So for example, as I mentioned earlier on, you might have part of your application on premises in VMs. You might have part containerized. You might be using some function as a service like Lambda. You also want to make sure that the service mesh you're using has the full shebang around install and lifecycle management. So the last thing you want is depend on a service mesh and then having a very painful time upgrading that in prod. So think about your runtime environment. Think, does the service mesh that you're looking at actually work across all these different environments, and does it come with the proper install and upgrading lifecycle management? Second, already mentioned a couple of times, and you will see coming back to that over and over again, you should consider cross compute. While it's very tempting to just go like, oh, right, everything is Kubernetes and everyone is using Kubernetes, reality is that's not quite the case, right? It's not the case that we have just one Kubernetes cluster and everything is fine. You will have to deal with different compute environments. So if your service mesh supports automated discovery across different compute environments, can handle authentication and authorization across different compute environments, then that's a great point. And you should, in doubt, pick that over something that only works, let's say, for example, in Kubernetes. And last but not least, and sometimes not so obvious criteria is around what I lumped up in availability, the total cost of ownership, and community. So for example, ask yourself, is the service mesh that you're looking at only available as open source, or as open source and as a managed offering, or only available as an SaaS managed offering? So you want to be sure that for your environment, for your setup, you can use the service mesh as you like and as you need to. Total cost of ownership. It's not just, it's open source, it's free. You need to train people. You need to make sure that you have everything tested and enabled to actually use that service mesh. So don't look at just what the actual cost for license or whatever are. Look at the overall package. Take into consideration training, what impact it has onto your overall setup, etc. And last but not least, does it have a community around that? That always helps. Before we all get very excited and say like, everyone doing service meshes everywhere, when I'd like to highlight maybe not to use service meshes. If you have a very homogeneous environment, think of that microservices setup I showed you earlier on, and you have everything written in the same language, let's say Go or Rust or Node.js or Java, you might not actually have a huge advantage introducing a service mesh in there. You might be better off with an in-process, with a library-based solution. Also, it's obviously a hard thing to say what is, a big enough number of microservices. But if you have a handful, 2 or 3 microservices, and maybe just a single team, maybe you want to postpone or reevaluate the introduction of a service mesh to a later point. Sometimes we hear from our customers also that they are not happy and not willing to pay what I call the sidecar proxy tax. So this sidecar, remember early on, sitting next to each of those services that actually has a value for you per se, or delivers a value into the application, consumes resources. And you could say, well, it's just one sidecar, but yeah, you might end up with a number of those, right? You might end up with some agent for observability, et cetera, et cetera. So you might have a sidecar to the application ratio from 1 to 3, 4, or 5. You might not be willing to essentially pay for that. If your offering is set up in a way that you do not pay for that, that's great. But you still might see this tax in the sense of an additional latency might be something that could be critical in low latency environments. Just consider that. Is it worth it? Does it really add the value there? And last but not least, let's not kid ourselves. Although we have many contenders in that space, the overall timeline, if you compare it with the container wars back then, 2015 to 2017 around, it's pretty much there, right? You have a lot of choice. It's a relatively new set of technologies. I'm not saying don't use it in production, not at all. You can and you should, absolutely. But be aware of that compared with the container setup, which again is for many people still understandably very bleeding edge. With service meshes, we are more or less one generation behind. We're even more on the bleeding edge. So that is a kind of warning there as well. Any of those, when maybe not, may help you and may guide you in when is the right time. I'm not saying you should not be doing it, especially when you start finding yourself reinventing the wheel. You're doing all of these things that a service mesh does for you out of the box. You find yourself doing that on your own. So let's move on to one of my favorite topics, and that is standards, or de facto standards, or specifications that strive to become a standard. So I call that slide towards standardization for a reason. If we look at the different data and control plane parts of a data stack, I would argue that in the data plane, the Envoy service, the proxy and the Envoy APIs can be considered nowadays almost as a standard, a de facto standard. I'm not saying that all the service meshes are using them. I'm very well aware of other service meshes that do not use Envoy in the data plane. I would, however, argue that Envoy has a pretty dominant position here. And there's also a working group in CNCF, UDPA, the Universal Data Plane working group that tries to take that a step further. In the control plane, we have another CNCF project called the Service Mesh Interface, SMI. We have a number of different startups and cloud providers being part of that initiative. We meet every 2 weeks, and we have really good progress there. I can encourage you to join or have a look at the recordings first before you join if you want to get an idea of what we're doing there. And SMI is, I would argue, developing and establishing itself as the control plane standard going forward. And I mentioned it earlier already with the challenges around observability. There, it's a pretty clear-cut thing that CNCF OpenTelemetry, which came out of the merger of OpenTracing and OpenSensors. And I remember last KubeCon, last real KubeCon, San Jose in end of 2019, a keynote there, where this was essentially broadly announced. And I believe in the next couple of weeks, the plan would be to go GA. OpenTelemetry has a huge buy-in, makes a lot of sense to standardize on these telemetry bits. So how do you get things like traces, metrics, logs from where it's happening from the different services in your microservices setup to a central place? How do you ship them? And where you can consume them downstream, and that is then the observability bit, where you can get insights, get alerted, have dashboards, etc., etc. Maybe even some machine learning in there. Last but not least, I do want to give a shout out to one very special technology that I believe has a huge potential. And what I've seen in the program of the Software Circus, there will be at least one other session that gives you a deeper dive and better idea than I can do on this one slide here. And that is BPF. BPF, formerly the artist formerly known as Berkeley Packet Filter, nowadays not much to do or not exclusively to do with packet filtering. What it really is, and we're using it now as a kind of term on its own. So you just say BPF, notice not eBPF anymore. The creators, the people who are driving that behind, make it very clear. What used to be eBPF, extended BPF, a couple of years ago is now just BPF. So RIDA is now Twix and eBPF is BPF. So what is BPF? BPF is essentially, think of it of a Linux kernel feature, I believe 4.11 above, that enables you to write, to safely and efficiently extend the kernel functionality in userland. So you write your program, your BPF program in Go, in Rust, in C++, in whatever. You have a mechanism to load it in the kernel. There's a verifier. There are certain constraints in terms of size, what you can use there, etc. You essentially, the guarantee that BPF essentially gives you is that you can't screw up. You can't screw up the kernel there. And then you can do whatever. And the way how the kernel, how BPF interfaces with your program is that there are maps, kernel structures, maps that you can then essentially read. This is more or less the output from the kernel, and you can do whatever with that information. So you load some BPF bytecode, which essentially BPF there is essentially a virtual machine, 64-bit, and then you can do whatever. And this, if you think about that, in the context of service meshes, allows for a number of things. Maybe even someday we can get rid of paying this sidecar tax and actually running these kind of data plane related things directly in the kernel. That would at least be my hope that this happens one day. So I see already Mark looking in my direction, kind of like, Michael, time to wrap up. And here's the good news. I am wrapping up. I have one more slide. And that is what's next. To me, service meshes, as I said, are super useful. And maybe I scared you a little bit too much. I hope I did not. Super useful technology. You should totally consider using them. Just don't feel rushed. Don't feel like, oh, service meshes, if I don't do service meshes tomorrow, I'm kind of like not one of the cool kids. You totally are. That's the reason why I created this service mesh manifesto, saying, here is what I think is relevant and makes sense. I think service meshes are a good thing, and they're here to stay. They're not a fad. They're not going anywhere. They might not be as explicit. It might fade into the background, and you see that happening in many different areas. I want to push any and every service mesh vendors that it should be possible to use service meshes across compute. Do not limit yourself to only work on Kubernetes. Kubernetes is a great place. It's definitely something you should support, but not the only one. The number 3, and here is a shout out due to the lovely folks from Buoyant. If you want to see how you do the UX right, Thomas, I'm looking at you here, then have a look at Linkerd. Right? Linkerd nails the UX, that is, or DX. That is what I would say. That's how easy it should be. So if you get on that level, you have more or less reached the goal. And last but not least, the cognitive and technical overhead that is introduced by the service mesh. Again, remember, service mesh are good. They do deliver value. They do allow you to tackle some of the really hard problems that you see with microservices, with the cloud native setup there, distributed systems. But the cognitive, so what is going on in ops and dev folks' head, should not be overloaded. So it should be something that is part of the fabric that allows you to do things, as we discussed early on: security, traffic shaping, progressive delivery, compliance, observability, etc. That should be possible to benefit from all these wonderful things that service meshes do for you without, ending up with scars from Edward service mesh hand. With that, I bow out. Thank you very much. I think I made it almost just in time.
That's fantastic, Michael. Thank you. And I'm sorry if I put you off by putting my camera on a little bit early. You are well within time. So obviously, as you pointed out, service mesh is a big hype topic at the moment. There's a lot of interest around that, and it's amazing to see that you've gone ahead and created this this manifesto to help people out, or at least to understand what good might look like for these service meshes. I think one of the questions that people are asking themselves a lot, and this is broader than service meshes, of course, is when do I need one? And what's a unique heuristic that might help me to decide maybe when I should start assessing, start implementing, or maybe just not even bothering? And I think this is kind of the same thing for all technologies, but a big thing we've seen with microservices and Kubernetes, of course, is everyone running in and then thinking, actually, I could have done this without half of the engineering.
I think that I try to hint at that in this slide, where you could put it the other way around. If you have not nailed the basics yet, if you don't have a fully automated CI, I'm a developer, I write code, I say, commit whatever, and at the other end, some container image, whatever, lands in a container registry. If you don't have nailed that, if you haven't got your CD sorted out, GitOps, etc., you can do, maybe even no QA, but directly do that in production and do AB and other things out there. If you have all of that sorted, you are in a position that you can focus on service meshes. If you haven't sorted that and you directly jump into service meshes, I guarantee you will end up like that.
Right. Yeah. So advice there: walk before you run.
Exactly.
Excellent. So we will probably share these slides afterwards, but you can find Michael quite easily on Twitter. Also, I believe Michael will be in the Slack, or you can reach out to Michael through the Bell app if you'd like to ask more questions there. Michael, you've been such a huge part of the Software Circus, and every time you come back, it's always inspirational. So thank you so much. I really appreciate it.
Thank you for having me. Thanks a lot.
A couple of quick shout outs before we go to the next one. Up next on Software Circus TV, that's track 3, we have the pumpkin carving part 1. So get in there, otherwise you won't be able to be part of the judging later. I want to give another shout out to our sponsors. That's Equinix Metal, Cycloid, Giant Swarm, Instana, and Kinfolk, who we didn't forget this time. Apologies for that, Andrew and friends. Again, if you're on the Brella app, you are automatically entered into a raffle to win a t-shirt. Go and check out the lineup. There's a bunch of other stuff coming up, and you'll hear back from me in about 45 minutes. Thank you, and bye-bye.